Okay, so is my screen is visible to you? And I'm audible to you? Just write it in the chat box. Okay, start recording. Okay, so hello students, how are you? I hope you are doing good. So, good evening to everyone. I hope this screen is visible to you and I am audible to you. If it is so, just write this thing in the chat box so that we can start the lecture. Okay. So Anvesha is here. JNB Bhavnagar is here. So please write this thing here in the chat box. The screen is visible to you or not? Okay, Anvesha. So we will wait for 1 minute more. Okay. Let the other students to be joined. Then we will start the lecture. Okay. Okay, JNB Bhavnagar. I got this. So here we are with the question discussion of laws of motion, the frictional part. Good evening, Lakshmi. How are you? Hope you are good. So here we are with the lecture number. Yeah. So JNB Bhavnagar, is any kind of doubt you have? The lecture has not been started yet. Okay, you are raising your hand, na? So okay. So firstly, in the previous lecture, what we have did is the question discussion on laws of motion. Okay, mostly talk about the connected bodies and all. Okay, pulleys and all. Okay, okay, I got it. So now the frictional motion of the object has been remaining. So I have covered it in two lectures. So the first lecture is going on. Second will be on Sunday, tomorrow. So here we will discuss some questions of friction and try to understand the concept of friction with the help of numericals. Okay. So it is the best way to learn the concept with the numerical. So here, so without wasting so much time, let's get started with this lecture. So yeah, the very first slide on your screen is this. Here in the question, a block of mass 1.2 kg has been given, which starts along a straight horizontal track with an initial velocity of 6 meter per second and come to rest after 4 seconds due to friction. So you have to find the force of friction on the block and the coefficient of kinetic friction. Let me first discuss. I will give you some time to solve this question, but not now. Let me first discuss some basic concept of frictions. Okay. We have two types of friction. Two types of friction. Or let me just uh, change the screen. Na? Yeah. So, so you have to note it down because this screen is not visible to you every time. Huh? So friction. So we have two types of friction, static and kinetic. जब तक बॉडी रेस्ट में रहती है तब तक आपका स्टैटिक फ्रिक्शन काम करता है. इट एक्ट्स व्हेन बॉडी इज इन रेस्ट. But when the motion has been started, then kinetic friction came into contrast. Okay. When body or system is in motion. Okay. Mostly the frictional force F is equals to mu times of the normal reaction force, or you would say the contact force. Okay. So this is the formula for static friction. It is mu s into m. And for kinetic friction, Fk, it is mu k into n. Generally, mu s, static friction coefficient, is greater than mu k. Okay. If it is not given, then you would consider mu s is equals to mu k. Okay. Now, this Fs, static friction, is adjustable in nature. Means it can adjust its value according to the external force applied. So this is a variable force. Okay. But is this is the constant value of force. Constant force. Okay. Once the motion has started, only the kinetic friction will act, and this friction does not change its value. Okay. Got it. This static friction, Fs, Fs can vary its value from 0 to 0 to Fl. Okay. This Fl is the limiting friction. Limiting friction means इससे ज्यादा static friction की वैल्यू नहीं हो सकती. This is the limiting one. Okay. So you will encounter some of the terms, some of the statement like when motion is just started, body just start sliding. So this just, no, it is saying that whatever the external force there is equating the value with limiting friction, because the maximum value that the friction can have, static friction, is the limiting friction. Okay. So at the statement like the motion is just started and the body is just started sliding, so you have to put the external force equals to the limiting force, limiting friction. Okay. So this is it. Please note it down. Okay. Or you can take the screenshot. I'm giving you 10 seconds for this. Okay. Just take the screenshot of it, or you can write it down. I think what I really think ki, when you are spending your 1 hour, na, so you do not waste it. At least some of the time of this 1 hour duration, you will have as a asset कि खाली हाथ नहीं जाना. हाँ, कुछ ना कुछ लेके जाना है साथ. Okay. So your 10 seconds is over. Now, again, back to the question. Now here, yeah. Now, based on the information I'm giving you, 1 minute to solve this question. Okay. Afterwards, I will start the solving question. Okay, let's say who is there. Anvesha is here. JNV Bhavnagar is here. Oh, JNV Bhavnagar. There are multiple JNV Bhavnagar. I think there are some students joining from the same school, na? Okay. Shalini Gohil is there. Vishal. Good evening to everyone. Okay. Try to solve this question. Okay. Now, your 1 minute is over. No one had got the answer. So I have to solve this for you. Okay. Good evening. Now, focus on the question. So let's say this is the block I have. Good evening. Good evening. This is the block I have. Now focus on the question. Okay. This is the block I have, mass of 1.2 kg. Okay. Now it starts its motion with a velocity initial is equals to 6 meter per second. And finally, this block comes at rest. Means the final velocity of the object is 0. Got it? Now we have to find out the force of friction. Obviously, there is a force of friction. That is why this object has come to rest. Na? Okay. So we have to find out the deceleration of the block. It is same as the acceleration, but opposite in sign. Okay. So how do we calculate the acceleration of this block? Acceleration is velocity final minus velocity initial divided by time. Delta V by time. Change in velocity per unit time is acceleration. So V final here is 0 minus V initial here is 6 divided by time taken is 4 seconds. This is given 4 seconds. So acceleration here is nothing but minus 3 by 2 meter per second square. Why this minus has come? Because it is in the opposite direction to the motion. It is same as the brake supply. Okay. So this acceleration is acting in this direction. Okay. Now, who is providing this acceleration? The frictional force. If this block is moving in this direction, so friction always opposes the relative motion. So it try to stop this by applying itself in the opposite direction. So this is the frictional force we have. Okay. Now, according to Newton's second law says that F net is equals to mass into acceleration. We have to find out the value of force of friction, and it is the only force which is providing this acceleration, which is negative. Okay. So frictional force is equals to mass of the system multiplied by acceleration. Means mass of the system is 1.2, acceleration is minus 3.3 by 2. Okay. So here you can say it is 0.6 and 3 6 is 18. So it is minus 1.8 Newton, which means it is acting in the opposite direction to the motion. Okay. And its value is minus 1.8 Newton. If you are interested in only magnitude, so it is 1.8 Newton. Okay. Now, how to find the coefficient of kinetic friction? I have told you when the motion has been started, only kinetic friction will act and will oppose the motion. Okay. I have taught you the formula, which is mu k into n is equals to kinetic friction. What is the value of n? N is the contact force, which is exactly equals to mg in this case. So Fk here is nothing but mu k mg. Fk की value हमें पता है, what is 1.8. Here we are taking the magnitude only. Mu k we have to find out. Mass 1.2 and g is given as 10. So 6 2 is 12, 6 3 is 18. So we have mu k is equals to 3 by 2 into 10. 2 divides 3 1.5 times divided by 10. So mu k is equals to 0.15. Okay. This mu k and mu s always less than equals to 1. But there are some exception for which this mu k and mu s can be greater than 1. Okay. Got it? So this is the solution of it. If anyone has any kind of doubt, you can write this thing in the chat box. Okay. Now move on to the next question. Yeah. So a body of mass 10 kg is kept on a horizontal floor of coefficient of static friction is 0.5 and coefficient of kinetic friction is 0.45. You can see here the static friction is greater than coefficient of static friction is greater than coefficient of kinetic friction, as I have told you. Now find the acceleration of and force of friction, contact force on the body by the plane when driving force is 40 Newton and 60 Newton. So here we have two cases. So I divide this screen in two part. Okay. First part we will deal here. Second part we will deal here. Okay. So this is the block we have. We kept this block in horizontal surface. Okay. It has mu s is equals to 0.5 and mu k is equals to 0.45. In first case, we will select the driving force. Driving force equals to 40 Newton. Okay. So, firstly, what do we have to find out? The acceleration of this block and force of friction and the contact force. Now, in this types of question, what you have to do, firstly, find the limiting friction for that. Okay. Why we are finding the limiting friction, I will tell you. Firstly, find the limiting friction. So FL is nothing but mu s into n because it is the maximum of static friction. So FL is equals to mu s, which is 0.5, n is mg, 0.5 times mg equals to, what is the value of m? M is 10 kg and g is also 10. So it will give you 50. Okay, 50 Newton. So our static friction can vary from 0 to 50 because it can have a minimum value of 0 and maximum value of limiting friction. And limiting friction in this case is 50 Newton. Okay. Okay. But we are trying to drive this block, with an external force of 40 Newton. So tell me, is it possible when the maximum value of friction is 50 Newton present here and you are applying a force of 40 Newton? So is it possible that this block would move? No, because to give the moment of this block, we must exceed the value of external force applied by us from the limiting friction. हमारे द्वारा जो लगाया गया force है, it should be greater than the limiting friction. It must be, okay, for the motion. Okay. So in this case, you can say, and this static friction, what is the value of static friction here? It is not the static, it is the limiting friction, the maximum value of friction. But what is the value of static friction here? I have told you that static friction is adjusting in nature. So for this block, we know that this block will not move because this 40 Newton will not exceed the value of this limiting friction. So for that, we have to apply a force equal and opposite in direction. So this Fs here is nothing but 40 Newton. So this Fs can adjust its value from 0 to 50. So it had adjusted its value to 40 Newton. Okay? That is why the block has not been. Okay. So Fs here is 40 Newton. Got it? Acceleration of the system is 0. Got it? Now, the contact force we have to find out. So here we have two contact force. First is the friction. Let me write it here. This is the normal force. This is mg. This is friction. So we have two contacted force here. First is the normal reaction. And the second one is the frictional force. Okay. So always remember this contact force is nothing but square root of frictional force plus normal force. Here you will take the frictional force as 40 Newton, not 50 Newton, because here the static friction will act and it has a value of 40 Newton. Okay. So it is 40 square plus what is the value of N? N is equals to mg. N equals to mg. And what is the value of M is 10. Ng is 10 also. So it is 100 Newton. So it is 100 ka square. You will solve this value. It is 1600 plus 10,000. So this will have some value. Okay. So you can rest it here. So this is the contact force that we have. Okay. Got it? Now in the second case, when driving force is, or any one of you calculate this value by the calculator, you can calculate. Just write the value in the chat box. Let me see any one of you can do this. When driving force is equals to 60 Newton. So here we are with the block and the 60 Newton force has been applied to it. In opposite to that, static friction will act because this is in rest initially. Okay. So here the limiting friction will also mu s into n, which is equals to 50 Newton. Limiting friction will not change its value. Okay. It is fixed. But the static friction can change its value from 0 to the limiting one. Okay. Here you can see this applied force. Yeah, this driving force. You can say the driving force. The driving force is greater than the limiting friction. So in this scenario, the body will start because the driving force exceeds the value of the limiting friction. Okay. So here, what friction must act when the body is in motion? What friction must act? The kinetic friction. Okay. And it has some acceleration in this direction. Got it? So we have to find out the value of this acceleration. So this acceleration by Newton's second law, F net is equals to mass into acceleration. What is F net? It is 60 minus Fk equals to mass into acceleration. Now, what is the value of Fk? Fk is nothing but mu k into n. This is the formula. What is mu k? It is 0.45. What is n? It is 100. We have calculated this here. N is 100. So it is 45 Newton. Okay. So 60 minus 45 equals to 10 into A. It is 15 equals to 10 into A. So A you have as 1.5 meter per second square. Now, what this? So the contact force here is, now the contact force, again the frictional, it is the resultant of friction force and normal force. So here the frictional force will be taken as kinetic friction because the kinetic friction is acting here. Okay. Into normal reaction ka square. What is kinetic friction? It is 45 square plus 100 square. This is, you can calculate, this is a value. Okay. So no one has calculated the value for me. It is not right here. Make this session interactive now. Now, move on to the next slide. So this is the next question that we have. It is same, but you clear the basic concept of it. So try to read it. Okay. So try to solve this question. I have given 1 minute to you. Okay. So a block of mass 5 kg is kept on a rough horizontal surface. The coefficient of friction for the contact force between block and surface are mu s, yani static friction is 0.1, coefficient of static friction, and coefficient of kinetic friction is 0.09. So horizontal force F is given by F is equals to 0.5 T. It is a variable force. Is applied at T is equals to 0. Okay. So initially the force is 0. Determine the force and the acceleration of the block as T is equals to 1, T is equals to 10, and T is equals to 12 seconds. Okay. Now again, we will divide this in two parts. Okay. So for T is equals to 1 second, we are going to solve. Okay. Got it? For T is equals to 1 second, we are going to solve. So at T is equals to 1 second, what is the value of force? F is given as 0.5 times of T. So 0.5 multiplied with 1 equals to 0.5 Newton. So this is the external force that we have, okay, which is applied on this block, equals to 0.5 Newton. Okay. Now this surface is rough, so it must exert a frictional force F in the opposite direction to the motion. Now calculate the limiting friction value. You will have to do it firstly. Okay. The very first step to find the limiting friction FL is mu of static multiplied with N. Mu of static is given you as 0.1 and the normal reaction is mg. So FL here is 0.1 times what is the mass? Mass of the block is 5 and g would be taken as 10. So it is 5 Newton. So the maximum value of friction, static friction, can be 5 Newton. ठीक है? So friction यहाँ पे static वाला जो friction है can vary from 0 to 5 Newton. Now what is the value of external force that has been applied? It is 0.5 Newton, which is very less than the limiting one. So static friction will adjust its value to the 0.5 just to oppose the motion, because it can oppose the motion. Why? Because the external force that we have is less than the limiting value of the friction force. Okay. So here we have FL is greater than this capital F. So this static friction will adjust its value to 0.5 Newton. Okay. And what about the acceleration of the block? So acceleration is 0. There is no motion can take place. Why? Because the friction balances the applied force. Okay. So net force on the system is 0. And initially the system is at rest. So it will remain in rest. Okay. Now, for T is equals to 10 second. Okay. Now what will happen? T is equals to 10 second में F we have 0.5 times of T, which is equals to 5 Newton. Okay. And the limiting friction, we do not have to calculate it again and again for the same case. FL is equals to 5 Newton we have. So our static friction can adjust its value from 0 to 5 Newton. And the applied force is also 5 Newton. So the static force can oppose it because it is in the range of it. So if this force is 5 Newton, the frictional force is also be 5 Newton. So यहाँ पे friction static will be 5 Newton. How can this be possible? Because the limiting value of friction is 5. So now static friction has adjusted itself to the 5 Newton. Okay. Now, what is the acceleration? Again, the net force on the system is 0. So acceleration will also be 0. Now, for t is equals to 12 seconds. Okay. For t is equals to 12 seconds, we must see. F is equals to 0.5 times of t. So it will become 6 Newton if we put the value of t 12 seconds. 12 5 is 60. Okay. So it is 6 Newton. Now FL we have as 5 Newton. So you can see here this external applied forces exceed the value of limiting friction. So now motion can take place. Motion will happen. Motion will happen. Okay. Now what is the net external force on this block? This is F, which is equals to 6 Newton. This is, or I must draw friction here. This is frictional force, which is 5 Newton, the maximum value it can have. So here, this static friction is not sufficient to hold this block. Okay. So here, the body will start moving, and when it start moving, so there is a friction. When body start moving, what friction will act? The kinetic friction. So Fk here is mu k into n. Mu k is 0.09 multiplied with n. N is mg, which is 10 into 5 or 5 into 10, you can say. Okay. So it will give you 4.5 Newton of kinetic friction. So F net, applying the Newton's second law, F net here is mass into acceleration. What is F net? It is F minus Fk. F minus Fk, which is equals to mass of the system, which is 5 kg into acceleration. Okay, what is the value of F? It is 6 minus 4.5 equals to 5 into 8. 6 minus 4.5 is 1.5. 5 into 8, acceleration is 5 3s are 15, so 0.3. So acceleration we have 0.3 meter per second square. Okay. Only in the third case it is possible to move the block with an acceleration of 0.3 meter per second square. Got it? We'll move on to the next slide. Yeah. A block of mass 5 kg rests on an inclined plane at an angle of 30 with the horizontal. So if the block just begin to slide, then what is the coefficient of friction between the block and the surface? And also find the acceleration of the block. Okay. Understand the question? There is a block of mass 5 kg has been given. Okay. And the inclination angle of this plane is 30 degree. Okay. If the block just begin to slide, I have mentioned this when I'm teaching you about the friction. This is very important. Just begin to slide, which means whatever the external force acting on this block is just equating its value to the limiting friction. Okay, got it? So just begin to slide mean concept here is FL is equals to the F external. This is the simple concept. Now, there is a force mg acting downward in this block. If I try to resolve this angle would be theta. So it is mg cos theta, and this component here is the mg sin theta. Okay, got it? Now, this mg sin theta try to pull the block in downward direction. So there is a frictional force will act to oppose this motion, and it act in the opposite direction to the relative motion. So this is the frictional force. Okay. Now, one force is also remaining here, the normal reaction. Okay. Now, solution part is mass of the block is given as 5 kg. Okay. Yeah. So here we have n is equals to, because there is no motion taking place in vertical direction. So the force is equal. This is x-axis and this is y-axis for this coordinate system. So n is equals to mg cos of theta, which is equals to 5 into 10, into cos theta is 30, cos 30 is root 3 by 2. 2 5 is 10, so it is 25 root 3 Newton. Okay. So if the block just start to move, then F limiting is equals to what? These forces are just equal. This F is equals to mg sine of theta. Is mg sine theta. Okay. Now this FL is mu times of n equals to mg sine theta. Now, what is the value of n? It is mg cos theta equals to mg sine theta. Mg and mg got cancel out. So you have tan theta is equals to mu. Theta you have provided as 30 degree. So tan 30 is 1 by root 3. So you have the value of, which is also equals to, as I know, 0.577. Okay. So that is how you are going to find out the coefficient of friction in case of just start the motion. Now, what is the value of acceleration we have to find out? So acceleration is simple. This block is trying to move in this direction. So I have considered the acceleration in downward direction. Okay. So F net here is mass into acceleration. So what is the value of F net? It is mg sine theta minus F is equals to m into a. Okay. What is mg sine theta? It is, you can say mg sine theta is, you can calculate the value of mg sine theta. M is 5 into g 10 sine theta sine 30, which is 1 by 2 minus, it is mu into n. N we have calculated earlier, which is 25 root 3 equals to mass of the block is 5 into acceleration. Now, this is 5 to the 10. So we have 5 to the 10. Okay. Now minus, this is 1 by root 3. Mu is 1 by root 3. So it is root 3 cancel out. So 10 minus 25 we have equals to 5 into acceleration. So it is minus of 15, 5 into a. Acceleration is minus 3 meter per second square, which means block do not accelerate in this direction. Block is accelerate in this direction. Okay, got it? So this is the solution of this question. I hope you got this. If anyone have any kind of doubt in this question or any previous question, you can ask in the chat box. Okay. So JNV Bhavnagar having any kind of doubt? Please write it in the chat box. Na? So this is a question from GME. Has been asked in 2019. Sir, A is equals to 0, Anvisha. In the previous one, na? Let me check. Mg sine theta here is, M is 5, G is 10, sine theta. Means sine 30. Sine 30 is 1 by 2. This 2 cancel this. Okay, 2 5 ja 10, na? 2 5 ja 10. Okay. This is the mistake, yeah. Very good, Anvisha. These are the silly mistakes, okay? It could be happen by you only. Okay, so this 25 minus 25 would give you the value. Very good, Anvisha. So you are the student, you are the one who is paying attention, deep attention to the question. It's good for you. Okay, I will tell you one thing, huh? Every one of you. If you are taking mechanics part of your physics very lightly, अरे ये तो हो जाएगा and all, you will suffer in each and every chapter of physics. Okay, this is the black reality physics. I must say you that weightage of 11th is 55% in GME and NEET also, and weightage of 12th is only 45%. So 11th is more important. I'm not saying that 12th is not important. 12th is also important, but in relative manner, 11th is more important. And this mechanics is the base of every chapter, you will see. Okay, this is laws of motion. You will see each and every question there is motion and all. Okay, each and every question motion is taking place. We have learned motion and all in the previous slide. In work energy theorem, you will also apply this motion, acceleration, force. Okay, got it? So this mechanics is the base of your physics, your conceptual physics. So please pay deep attention to it as Anvesha paid. Okay. Now solve this question. You have 1 minute to solve this question, or you will take 1.5. Okay, 1 minute and a half. Try to solve this question. A block of mass 10 kg is given, which is kept on the rough surface. A force of 3 Newton is applied on the block. The coefficient of static friction between the plane and the block is 0.6. Okay. This is the coefficient of friction is given. Now, what should be the minimum value of force P such that the block does not move downward? It is similar to the previous question. Similar. But there is only 3 Newton force is extra applied. Okay. Meanwhile, it is same. Try to solve this question and find out the answer. Okay. So mu here given as 0.6. Okay. Mass of the block is 10 kg. Got it? One thing more, this mu has no dimension. No? It has no unit. It is unitless or dimensionless because it is the ratio. What should be the minimum value of force P? We have to find out. So this is 10 kg block. This is a force P, and there is an external force 3 Newton is also there. This is the force mg. This angle is theta, which is given as 45. This component will be mg cos 45, yeah, cos theta initially we will say, and there is a component in this direction which is mg sine theta. Also, this surface is rough. Huh? So this surface is rough. So what should be the minimum value of force P such that the block does not move डाउनवर्ड मीन्स ब्लॉक नीचे मूव करना चाह रहा है. So there is a value of friction which is acting upward to oppose the motion. Okay, and to support P. Got it? So it is very simple. Now you just have to equate the values. Here, what you will have? You will have this P plus F equals to 3 plus mg sine theta. Simple. That is how this block is going to be in equilibrium na? If the net force is 0. So force on the upper side is equal to the force on the downside. Got it? This F here you should take here is mu n, which is mu mg cos theta, because n is equals to mg cos of theta. Got it? So put this value P plus mu mg cos theta equals to 3 plus mg sine theta. Okay. P plus, what is mu? Mu is 0.6, m is 10, g is also 10. Okay. I have taken 10 because it is given. Take g is equals to 10. Cos theta is 1 by root 2 equals to 3 plus m is 10 again, 10. Sine theta is 1 by root 2. Okay. So in the left hand side, you will have P plus 60 by root 2, 3 plus 20 by root 2. So you will calculate the value. P is equals to, it is 3 plus 20 by root 2 minus 60 by root 2. So P is equals to 3 plus, or we would say minus 40 by root 2. So this value in resultant approximately to 31.18. So you can approximate it to 32 Newton. So this is the value of P if you solve it. Okay. Got it? This is 3 Newton force. Do not forget it. Okay. So option A is the correct option. Got it? Now move on to the next question. Any kind of doubt you can ask. Now, yeah. So this question, before trying this question, I ask you to try this question. You have 1 minute to solve this question. This has been also asked in GMAIN 2020, September 6. Okay. So an insect is at the bottom of a hemispherical ditch of radius 1 meter. It crawls up the ditch but starts slipping after it is at height h from the bottom. Now, if the coefficient of friction between the ground and the insect is 0.75, then h is equals to. So here in this question, this is the hemispherical ditch. डिच माने गड्ढा, ठीक है ना? वो तो होते ही हैं इंडिया में, है ना? So this is the hemispherical ditch. But what happens this time? इस बार किसी का व्हीकल नहीं फंसा इसमें, ये छोटा सा इंसेक्ट फंस गया, है ना? So this is the center of this hemispherical ball. Now here it is given that an insect is at the bottom of the hemispherical ditch. Initially वो कहाँ पे है? Bottom. This is the insect. Okay. Now it crawls up and the ditch but starts slipping after it is at height h. So let's say ये यहाँ पे पहुंच गया, which is at a height of h from the bottom point. This is height h. इसके बाद क्या हुआ? It start crawling down. स्लिप करना शुरू कर गया. Now, if I just extend this, just meet this point. This angle I have considered theta. Okay. Now, at this point of time, mass of the insect acting downward, normal reaction is acting in this direction. Why it is so? Because it is a hemisphere. So contact force means normal forces always act perpendicular to the contact surface. And if I draw any perpendicular to the hemispherical surface from its periphery, it must cross the center. Okay. So this is an, if I try to resolve this in this direction, let's say this height is h. Yeah, I have to mention it. This is h. This is the component. This angle is theta because from the vertical, this line is making angle theta. So this is the same line making an angle theta with the vertical. So we have a component in this direction which is mg cos theta and a component in this direction tangential to the hemispherical surface which is mg sine theta. Now this mg sine theta is responsible for this, all what is happening with this insect. So this mg sine theta trying to pull this insect downward. So there is a friction acting upward direction in the same but opposite direction. Okay. Now what is happening now? जैसे जैसे this insect is crawling up, so this theta is increasing. If theta is increasing, if theta increases, then sine theta will also increase. Means this downward pull is increases. So that is why after achieving a height edge, it start crawling down. Okay. So at that point, what is happening? At that point, this frictional force and this mg sine theta must be equal just before starting the down crawling. नीचे आने से जस्ट पहले क्या होगा? This friction force must be equals to this mg sin theta. So you can apply that. This F here is equals to mg sin theta. And N here is nothing but mg cos theta. What is the value of F? It is mu N and N is mg cos theta equals to mg sin theta. Now you have the value. You do not have the value of theta. No problem. Mu you have as, it is given as 0.75. So mu here is 0.75. So 0.75 times mg and mg got cancelled out. So it is equals to, if I take cos theta on the RHS, so it would become sin theta by cos theta, which is tan theta. So tan theta here is 3/4. I have write the 75 to 75 by 100. Okay. I can write it. So 25 3s are 75, 25 4s are 100. So 3/4. You must remember this triangle in which this side is 3, this side is 4. So this side will be 5. 3, 4, 5. Okay. This angle has the smallest side. So this is 37. This angle is 53. This angle is 90. Okay. You must remember this triangle. Okay. Now what do we have to find out? We have to find out this height h. Now, if I draw it in an extended manner, this is height h from the bottom of it. This is hemispherical bowl. Okay. This entire distance is radius. This is r and this is theta. So I can resolve this r into this and this component. Okay. So this component would become r cos theta. So what about this height? This height is r minus r cos of theta. So h here is r minus r cos theta. I can calculate the value of cos theta from this triangle. So cos theta here is, or you can say this tan theta is 3 by 4. And we got to know that hypotenuse is 5. So cos theta equals to base, which is 4, 4 over 5. So 4 by 5. So h here is r by 5, taking the LCM. So what is the value of r? R is given as 1 meter. So 1 upon 5. It will gives you the value at what? 0.2 meter. Okay. So height here is 0.2 meter or 0.20, 0.2, same. Option A is the correct option. Okay. I hope you got this. If you have any kind of doubt, you can ask. Otherwise, we have done with the today's lecture. Okay. So, have any kind of doubt in any question? You can ask. We will discuss the remaining question. Only one question is remaining. So, we will discuss it in the next lecture. Okay. So, it's wonderful, guys, attending the session. Okay. So, only Parul is here. Okay. So, I'll stop share this and I'll stop the recording of it. So, thank you so much, Parul, for attending the session. Okay.